Today we're going to build a scene-like camera, a lot like the one that you see here in the scene view. We're going to transfer that into the game view so that when we play the game we can get the same kind of actions where if you're clicking down on the scroll wheel you can anchor and move around the scene. If you right click you can rotate the camera. You can use the WASD keys to move, as well as being able to double click and focus an object. Okay. The first thing that you want to do is create yourself a scene with some simple objects that have colliders on them. Okay, I should mention that the double click doesn't work unless your object has a collider on it, and all of my objects have a collider so that they can be focused on. Alright, once you have a scene set up, click on your camera, add component. We're going to create a new script called, we're going to give it an appropriate name, something like scene like camera. You can see that I've already got one on here. We're going to create a new one called scene like camera, create and add. We should see that component appear on the main camera. We're going to double click on that. Okay, when you get in there, you're going to need to take out the start method, and we'll put in fixed update and late update. These are the only three callbacks that we need right now. Okay, so this is probably the highest level thing that we can do here. These are sub steps to what we're trying to achieve. Okay, so let's get these keys set up. Let's do serialized field private key code. Alright, we're going to copy that so that we can quickly move through here. I'm going to say forward key, key code. We'll map that to W for the time being. We'll default these to common keys. Key code S, right, for the back key. The left key, typically people use A, and for the right key, people use D. Right. So those are the movement keys, the basic movement keys if you want to use left, right, forward, back without having to anchor the camera. Okay. For anchoring the camera, we'll say that we've got another, we'll have another anchored move key equals key code. Let's say that is the middle mouse button. So mouse 1, and you can see here, middle mouse button. Okay. Right mouse button. So mouse 2 is the middle mouse button. Okay. And then the anchored rotate key equals key code mouse 1, and that's the right mouse click. Okay. Okay, we're going to need two more variables. Here we're going to start a header about the movement variables. Just saying that this is a private float for move speed, how quickly our camera moves forward, back, left, and right, or with the anchored movement when we're clicking down on the middle mouse button. Okay, and we need another variable, vector3 move variable. Zero that out. And this is in the scope of fixed update. It changes on every single frame, so we'll leave it here. We don't need to keep it as a class update, as a class variable. Okay, let's get input. So if input dot get key down, get key, key code, forward key. So if we're clicking on that forward key, right, what's our camera going to do? Move is going to increase by vector3 forward times move speed. Okay, so we're adding to this vector 3 1 in the forward direction times our move speed. So every second we will go 5 meters forward. Okay, now that we've got the forward key set up, we're going to set up the rest of those keys. We'll have back, left, and right. Let's stub in those values. Got the left key and the right key, and then we need to change the direction in which we're moving on all of these. So back, left, and right. Oops. Okay, how do we make it move? We access the transform of the camera. We translate to that vector, okay, in that vector, right? So let's save this. Let's go into the scene. Press play. Okay, I'm pressing W, S, A, and D. It's a little fast, so we can change that here in the inspector. It's actually a lot better this way. Okay, so around 1 is pretty good. Now we need 2 more variables. We need the mouse movement on the y-axis, and that will be input get axis mouse y. We need the mouse mouse movement on the x-axis, the horizontal axis, and that's get axis mouse x. Make sure to spell these right, otherwise you won't get these. You'll get a bunch of errors in the console. Okay, so this is vertical movement of the mouse, and this is horizontal movement of the mouse. If you're going to the left, it will be negative. If you're going to the right, it will be positive. And the same for Y. If you're going up, it's positive. If you go down, it's negative. Okay, keep that in mind as we move the camera. Okay, so if we have the input.get key anchored move key held down, then we're going to move the camera. Okay, we're going to add to the movement. Okay, so let's access the up and down movement first. So we're going to move up times mouse move Y. Remember, if this is negative, then this will become down. Okay, I know that's a little confusing because it says up, but if we multiply a positive value by a negative value, it becomes negative, obviously. We're going to move that by move speed. Okay, we're going to do the same thing with our left and right movement. So vector 3.right times mouse x times move speed, and that'll automatically go into the game, into the play mode, without changing anything else, because that vector that we're accessing is already being worked on by transform translate. So let's go into the game mode, let's go into play mode and see that in action. Okay, so again, I'm pressing WASD. Now I'm clicking on the right, on the middle mouse button. As I move up, the camera moves up. As I move down, the camera moves down. So that's not what I want. I want it to move in the opposite direction, right? So in scene view, if I move to the left, if I move my mouse to the left, I move right in the scene, right? If I move up on my mouse, I'm moving down in the scene. So I'm moving my mouse up, I'm moving down in the scene. So let's change that real quick. So in order to invert that movement, all we have to do is multiply it by negative move speed. Okay. So now you can see that as I move my mouse up, I move down in the scene. In the game view, as I move my mouse down, I move up. Okay, and the same for left and right. I'm moving my mouse to the left, and I'm moving right in the scene. I'm moving my mouse to the right, and we're moving left in the scene. Okay, now we're going to do our anchored movement, our anchored rotation, so that when we are clicking on the anchored rotation button, that is the right mouse button. Okay, that is our anchored rotate key. We're going to rotate the camera, okay, to the left, to the right, up and down. Okay, we need a new variable, we need a new speed. Okay, this is going to be our rotation speed. That'll be 5. Okay, so what are we going to do? We're going to access, transform, rotate around. Okay, so we have 2 signatures here. We can rotate about the point that we're at, the point at which the camera is. Okay, for horizontal movement, for up and down rotations, looking up, looking down, we're going to rotate around the camera's right axis. Okay, the left to right axis. Okay, and at an angle of mouse move Y, so when we move the mouse up and down and rotate, move that by rotate speed. So in the scene view, we see that if we hold the right, if we right click and move up, the camera moves up, and the opposite is true. Okay, so let's press play and make sure that that's what's happening here. I'm moving my camera, I'm moving my mouse up and the camera's moving down. So we need to invert that value just like we did with the move values. So we come back to the code and we invert that speed. Okay, all we have to do is make it negative. Okay, let's get that left and right rotation. So we'll transform, rotate around, and this is the same thing as what we did before. We're in the same position, but this time we're going to rotate about the up axis, okay, about the Y axis. All right, and we're going to move at an angle of the rotation speed times mouse move X. Okay, so depending on how far to the left or right you move your mouse, that's how fast you will rotate the camera. Okay, so let's save and let's test that in the scene. Okay, let's see the desired movement in the scene view. Okay, so if I'm moving my mouse to the left, the camera moves to the left and vice versa. Let's go into game. Let's press play. So I'm going to move to the left, perfect. I'm right clicking, I move to the right, and the camera moves to the right. So this one worked as expected. Okay, we're almost finished as far as movement is concerned. Now we're going to do the scroll, so that when we scroll the mouse, we'll zoom in or zoom out. Okay, so we'll get another float. We'll say that mouse scroll equals input dot get axis mouse scroll wheel. Now, if you don't know how that's done in input, you can go into edit, project settings, input manager, and then you have a list of the axes. So it is mouse scroll wheel with a capital W. Okay. So we'll cache that, and then we'll go into transform.translate. We're going to move it forward. Even if we want to move back, if we want to zoom out, we're going to put this again. We're going to multiply this by vector 3 forward, mouse scroll, and then we'll have another variable that we need to set, which is zoom speed. We'll just say that's 5 again. That's pretty good. Okay, copy and paste. We'll test that. We'll save it and test it. Okay, so this is the desired result. Let's go into the game and check that it's working. Okay, maybe a little slow compared to what they've got in the scene camera, so we can increase that zoom speed. Try like 10. It's a little bit better. Okay, Let's try even 15. Maybe that's around perfect. Yeah. Now we're going to do the last part of this tutorial, which is the focus object part, where if we double click on something, then we focus, we move the camera to that object and we focus it. So we need another variable. Okay, this is going to be the limit, focus limit. And that's the limit at which we won't focus an object. That is, if it's too far away, we won't go to it. We need another float that tells us if the mouse was clicked in the last frame or recently. Okay, so we'll say double click time. Probably not the best name, but whatever. We'll have a float cooldown. So if the cooldown is above 0, then we have clicked in the last 0.25 seconds. Okay. So we're actually going to take a look at that real quickly. So if the cooldown is greater than 0, then we have clicked in the last 0.25 seconds. So if we get another click, right, if we get key down, KeyCode dot mouse 0, then we're going to focus object. Okay, and we're going to write a routine called focus object. Super easy. If you right click, quick actions and refactorings, and then generate method, okay, you'll see that happens for you. Okay, and then we're going to have another if statement where if we click on the mouse button, then we set the cooldown to double click time. Okay, so it'll be greater than 0, and it will allow us on the next frame or next few frames to be able to focus the object, right? Okay, so, and then we need to lower the cooldown by time.delta time. Good. Save it. Nothing's going to happen yet because we haven't written anything into focus object. Let's get. Okay, so in focus object, what we need to be able to do is, if we have a double click that's aimed at an object, right? So if we are looking at an object in the scene, go to its position. Right. So how do we know where it is? Okay, so we're going to fire a ray at it, and then if it's got a collider on it, then we can get its position. And if you haven't noticed that when you're in scene view and you want to focus on something, if you click on it in the hierarchy, the focus is based on the size of what you're trying to inspect. So to demonstrate what I'm talking about, let's take a look at some of the objects in my environment. Okay, so I double click, I focus on the environment, I focus on my building placer. It's smaller than the environment, so it's a closer focus. I go to the ground, it's a big object, it zooms out a lot, right? So the first thing that we want to do here is create a ray. This is a ray that's shot from the main camera, screen point to ray, and it goes to the mouse position in the world. Okay, and then we need a raycast hit to collect information about what the ray hits. So let's cast the ray, physics.raycast. We're going to go ray out hit, and then we have that focus limit, so we'll go to that distance. We'll shoot the ray to that distance. Inside of here, we will say that if we've hit an object, then focus on that object. Without getting too far ahead of myself, let's just go ahead and move the camera to the target's position. Okay, to our focused object position. So we're going to say transform position equals target pose. Okay, and that's going to put us inside of the object. It'll put us right at the center of the object. Okay, and we'll test that here. So we enter play mode. we'll click on one of these boxes and we're going inside of the box. Okay, we're going right to the center of its position. So in order to not be in the center of the object, we're going to add an offset, and we'll do a kind of a prototyping here. We'll add a basic offset where we're 2 meters above the object and let's say 5 meters behind it. Okay, and then we'll look at it. All right, so we'll rotate our camera to look at our object. Okay, so that's the target.transform. Okay, so let's test that out in the game view. So we'll click on it and we'll go 2 meters above and 5 meters behind, right? And at the same time we're looking at it. So let's click on that one more time. Okay, click on the one to the left. Perfect. Okay, so you can see that even though we're over here off to the side, we're going to go to the -5 position. All right, and that's the Z -5. So in order to get an offset that puts us behind the object in our current rotation, what we're going to do is we're going to create a new vector3 and we're going to say get offset, and this will give us an offset that works for both the size of the object and the direction in which we're looking at the object. So we'll pass in the target position and the target in size. Okay, so we're passing in 2 vector3s. We're going to first create a direction. Okay, so that is the direction to target, and that is the target position minus our camera's current position. Okay, and we're going to return that as negative direction to target. All right, so we need to add to this the size of the object that we're focusing on. We'll say that the focus distance, so we'll create a new variable called focus distance, and we'll say that that is the maximum of the target size X, so either the width or the target size Z, or the length. Okay, so if the width is bigger than the length, then this is what we'll get for focus distance, and that's the distance away from the focused object that we will be. Okay, what we also need to do is say that if we have a really small object, we'll still be inside of it. If the target size that we pass in is really small on the X or the Z, then we'll be super close, and it'll give us kind of a jarring look at it. So what we're going to say is focus distance equals math clamp. Clamp that value to a minimum, all right, and a maximum. So let's actually create that minimum here. We're going to say the minimum min focus distance, and we're going to say that the minimum distance that we're going to be away from the target is 5 meters. Okay, so we can be no closer than 5 meters, and we're going to pass that in to math clamp. Okay, min focus distance, and then the maximum is either the target size X or Z. Okay, and I have to fix that. So we have target pose here, we need target size here. Right, okay, so and then we're going to multiply direction of target. We're going to normalize it, so it's a value from 0 to 1. We're going to multiply that by the focus distance. Okay, so we'll save, we should add it to our camera position. So when we move our camera, we're going to go to the target's position plus its offset, which is target pose and target size. Good. Save. We'll test it. Okay, let's test it. So you can see that the direction is different. Now, if we're to the side, you'll see that the camera looks at it from the side, and we're far away depending on what we select. So I'm selecting a small object, I select a big object, and I'm farther away with the bigger object. I can put a little tiny couple of objects here and select those, so we get closer depending on how small those objects are. Now these are very small, so this defaulted to the minimum value that we had set up, that 5 meter minimum value. And I'll show you that right here. We can change it, and you'll see that we get even closer. Okay, so let's say that our minimum focus is 2, so we get even closer to that object. All right. All right, that's pretty much the end of the video. For organization, I use the headers, and I keep all the native callbacks, all the updates. I keep those together, and I am moving my custom methods to the bottom of the screen. All right, that's it.